we are going to talk about the circular motion. Okay, so now what is circular motion? So suppose there is an object which moves along circumference of circle, its motion is circular motion, right? So there are few basic definitions regarding this circular motion. So first is angular displacement. Now what is angular displacement? It's just like our linear displacement. Okay, so here see, in case of linear displacement we take shortest distance between start point and end point. Now what is the angular displacement? So suppose you have this object and it is moving along circumference of this circle. So when it moves from this point A to the point B, okay, its trajectory or its path is an arc of the circle, and that arc makes some angle at the center. It is known as angular displacement. Okay, as simple as that. It moves along the circle, then its path, if you take that arc, okay, it makes some angle at the center. It is known as angular displacement. Now this is displacement, means it's a vector quantity, right? So it will have magnitude as well as direction. Okay, so it has got magnitude as well as direction. So now magnitude is just the magnitude of this angle. So we know how to measure the angle in radians, right? So it is the length of this arc divided by radius. Okay, so we know theta is equal to what? Length of arc, that is length of this arc AB. Okay, S divided by R. R is the radius, right? Now how to find out its direction? So there is a rule to find out its direction. It is called as right hand thumb rule. Okay, so what is right hand thumb rule? So take your right hand, curl the fingers of your right hand in direction of motion of this particle along the circumference of circle, and stretch your thumb. So your stretched thumb will show the direction of angular displacement. This thing is clear? Yes, no? Everyone? Okay, so now tell me what will be the direction of angular displacement of this particle. It is moving in anti-clockwise sense in this circle. Yes. Into the plane or outside the plane of your screen? Tell me. Just apply right hand thumb rule, curl the fingers of your right hand in direction of motion of this particle and stretch your thumb. Tell me, is it into the plane or outside the plane? It is outside the plane of the screen. Yeah, very good. So the direction is outside the plane of your screen. Okay, right now. All right, so this is angular displacement, and just like we define the linear velocity, which is displacement divided by time, we define angular velocity. Now this is average angular velocity, so it is just total angular displacement divided by time. Okay, so it is angular displacement divided by time. So omega, this letter is called as omega. It looks like W, right? There is no difference between omega and W. Okay, but we call it as omega. Angular velocity, it is denoted by letter omega, right? It is a little bit curly W, but some people just like W like this. Okay, so practically there is no difference. So this is omega. Omega is angular displacement, angular velocity. How do we define it? Angular displacement divided by time, and I have put suffix AV, right? AV to show that it's an average angular velocity. So what is average angular velocity? Angular displacement divided by time. What would be its unit? So unit of an angle, SI unit is radians. So unit of angular displacement is radians. Therefore unit of angular velocity would be radian for this angle divided by unit of time, that is second. So unit is radians per second, right? That's very, very simple. After that, next is the instantaneous angular velocity. So we know how to find out an instantaneous linear velocity. What is that? It's just derivative of linear displacement with respect to time, or you can say it's derivative of position with respect to time. So just like that, we have instantaneous angular velocity omega bar. So here I haven't put the suffix average, okay, av. So omega bar is equal to what? Just d theta bar by dt, okay, rate of change of angular displacement with respect to time. So this thing is clear, yes, no? Right, everyone? Okay, now tell me what will be its direction. What will be the direction of angular velocity? Same as that of angular displacement, right? Direction of angular velocity will be same as that of angular displacement. Okay, good. Then next let's talk about the angular acceleration. Now what is linear acceleration? Change in velocity divided by time. So what would be angular acceleration? It is just change in angular velocity divided by time. So suppose omega naught is initial angular velocity at time t equal to 0. Omega t is angular velocity at time t, okay. So what would be average angular acceleration? So it is just omega t, okay, omega t bar minus omega naught bar divided by time. So this is change in angular velocity divided by time, and unit is just radian per second square, just like our acceleration has, linear acceleration has unit of meter per second square, right? So this is average angular acceleration, okay. And if you want instantaneous value, so every time you want an instantaneous value of any quantity, what do you take? You take a derivative, right? So alpha bar would be what? Derivative of omega bar with respect to time, okay, d omega bar by dt, okay, right? So now tell me what would be its direction. Average angular acceleration or instantaneous angular acceleration, what would be its direction? Tell me, anyone? Is it same as that of angular displacement or angular velocity or something else? It's very, very simple. See, if angular velocity is increasing, the acceleration is in same direction of angular velocity. If it is decreasing, means acceleration, the angular acceleration is in opposite direction of angular velocity, right? If angular velocity is increasing, that means your object is moving faster, okay, its speed is increasing, it covers those angle rapidly, right? Then what will happen? The angular acceleration is in same direction as that of angular velocity. But if the angular velocity is decreasing, then it is in opposite direction. This thing is clear? Yes, no? Okay, Nikita, is it clear? All right, good. So then, so I have written it over here. If omega t is greater than omega naught, the angular acceleration is in same direction of omega, otherwise it's in opposite direction, right? So that's very, very simple. Now see, what is uniform circular motion? So if speed of an object remains constant in the circular motion, we call it as a uniform circular motion. Okay, speed remains constant, not the velocity. Okay, speed and velocity are different things. So what is speed? It is magnitude of velocity. Okay, what is speed? It is magnitude of velocity, right? So then the time period, or it is also called as just period or periodic time. Okay, different names. So time period of an object performing circular motion is just the time taken by the object to complete one revolution along the circumference of circle. Okay, time period is time taken by an object to complete one revolution along the circumference of circle. Very simple. Then let's talk about the relation between the linear speed and angular speed. Okay, so all these things are very simple. See, we have defined angular speed. What's that? Omega is angular speed. So now it is angle covered per unit time. So now in one revolution, how much of angle will be covered? How much of an angle will be covered? It's 2 pi, right? In radians, in one revolution, angle covered would be 2 pi. So you have angular speed is equal to what? 2 pi divided by t, right? Then you have linear speed. So what is linear speed? The distance covered in one revolution divided by time taken. So that is distance covered is circumference of circle, 2 pi r, divided by time taken is capital T. Okay, that is time period. Time period is denoted by capital T. So linear speed is equal to 2 pi r divided by capital T. Angular speed is 2 pi divided by capital T. So what's the relation between them? This linear speed v is equal to what? R multiplied by 2 pi by t, that is angular speed. So v is equal to r times omega. Okay, v is equal to r times omega. This is very simple, right? Okay, good. Then next we define frequency. So what is frequency? So number of revolutions performed by an object per unit time. Okay, so number of revolutions performed by an object per unit time is the frequency. So it is just reciprocal of time period. Okay, frequency is just reciprocal of time period. So now frequency, you can denote it by n, you can denote it by nu, you can denote it by f, different letters. Okay, so now you have omega equals to 2 pi divided by t, right? Omega is equal to 2 pi by t, and 1 upon t is frequency. So therefore omega, there is another formula. So 1 by t is frequency, 1 by t is n, therefore omega becomes 2 pi n, right? Therefore omega becomes what? It becomes 2 pi n, right? That's very simple. Okay, so we are starting from very basic things. All right, after that, now let's understand some concepts. Okay, so these were also so whatever we saw till now are very basic concepts. Okay, so now let's talk about the tangential acceleration. So what is tangential acceleration? So in circular motion, an object revolves around circumference of circle. Okay, you can take an example of a stone tied to a string. Okay, nobody does that nowadays, but suppose you take a stone tied to a string and you whirl it like this in a circle. So now suppose you release it at this point. Okay, so let me suppose you are revolving it like this, you release it at this point. What will happen? It will come like this towards you. Okay, you release it here, then it will go in this direction. You release it here, it will go in this direction. You release it backwards, then it will go in that direction. Okay, in what direction? It always goes along the tangent, right? It always goes along the tangent, and that tells you that in circular motion the velocity is directed tangential. Okay, so for an example, this is that stone which is tied to a string and you whirled it in this circle. Okay, so at this point its velocity will be directed like this. At point B the velocity is directed like this. At point C the velocity is directed like this, and at point D the velocity is directed like this. So now velocity is directed along the tangent, that's why it is called as tangential velocity. And if there is change in the magnitude of this tangential velocity, okay, earlier suppose it was 1 meters per second, now it's 2 meters per second, then there would be acceleration, right, because of change in magnitude of this tangential velocity. Okay, so tangential acceleration is the acceleration in circular motion due to the change in magnitude of velocity. Okay, this is because of change in magnitude of velocity. So now how to find it out? So simply the way we find out acceleration, suppose v1 is the speed at time t1 and v2 is the speed at time t2, then what is tangential acceleration? It is just v2 minus v1, the change in speed, divided by change in time. Okay, so v2 minus v1 divided by t2 minus t1, right? And then we just saw that v can be written as r times omega, right? So v1 is equal to, I can say, r times omega 1, okay, angular speed at time t1. v2 is equal to r times omega 2, angular speed at time t2 is omega 2. And if you just substitute that in this formula, then what do you get? R you can take common, it's omega 2 minus omega 1 divided by t2 minus t1. And what is this thing? So omega 2 minus omega 1 divided by t2 minus t1 is angular acceleration, that we denote by alpha, right? So the tangential acceleration is equal to r times the angular acceleration. The tangential acceleration is equal to r times angular acceleration. This thing is clear, everyone? Yes, no? Right, tangential acceleration is r times angular acceleration. So there are two things to be remembered. It is because of change in what? The magnitude of velocity. Okay, this is one thing, right? And second thing is it is r times angular acceleration. So if angular acceleration is 0, means the object moves with constant angular speed, that is object moves with constant linear speed. Okay, right, both are equal or equivalent, you can say. If angular speed is constant, if omega is constant, means v is also constant. Okay, so if object moves with constant speed, then what will be the tangential acceleration? It will be 0, right? If there is no change in speed, what will be tangential acceleration? It will be 0. Yes, no? Right. So this is one type of acceleration that's there in circular motion. There is another type of acceleration too, and it is called as centripetal acceleration. Okay, it is known as what? Centripetal acceleration. So now remember this thing, this acceleration in circular motion, this is the acceleration in circular motion due to change in direction of velocity. Okay, so tangential acceleration will be there if there is change in magnitude of velocity. The centripetal acceleration is there due to change in direction of velocity. Okay, and in circular motion the direction of velocity is never constant, right? So for an example, suppose the speed is constant. Okay, so this is the speed at point A, let's say VA. So if I want velocity, it is directed like this. Okay, so this thing will be VA bar. Now at point B, when object moves from A to B, if speed remains constant, speed can remain constant, right, but its velocity is directed like this. Okay, so this is VB bar, right? And then this vector is VA bar, this vector is VB bar. You can never say that this vector and this vector is equal, right? They are different because they are directed in different directions. Okay, their magnitude can be equal, their magnitude is equal. In fact, if the speed is constant, then the length of this vector VA bar is equal to length of VB bar. Okay, so that shows that speed is constant, magnitude of velocity is constant, but their direction is different. So if direction is different, means the velocity is changing, and the acceleration because of this change in direction of velocity, it's called as centripetal acceleration. So this thing is clear. Okay, what's the cause of tangential acceleration? What's the cause of centripetal acceleration? Okay, good. So centripetal acceleration is due to change in direction of velocity. So now this is always present in circular motion. So we'll take an example of uniform circular motion, because this acceleration is because of what? Change in direction only. So now suppose I'm sorry, suppose this is your object, it's at point A, then velocity is directed like this. When it moves from A to B, okay, when it moves from A to B, what will happen? Its velocity at point B is directed like this, and this is VB bar. I want to subtract VA bar from that to find out change in velocity. So what I do is I take this VA bar, I put it at this point, and using triangle law of vectors addition or subtraction, I subtract it. So then this is my VA bar. I have taken it from here and put it at point B. Okay, so this is VA bar. I want to subtract it from VB bar. So I see that VA bar plus this vector, okay, will give me what? VB bar. That means this vector is delta V bar. It's VB bar minus VA bar. This thing is clear? Yes, no? Right? Delta V bar is equal to VB bar minus VA bar. Okay. So now suppose your object moves through an angle of delta theta when it goes from A to B. So now we know what is delta theta. It's equal to arc length divided by radius. Okay, it is equal to length of the arc divided by radius. Right, this is clear till this point. All right, so this is just a definition, right? So then for very small angle, I can say arc length is just equal to, so see, your object was here, so this is position vector at point A, when object is at point A. When object moves from here to here, the position vector becomes this RB bar. So what is change in position, or what is displacement? This is the displacement. Okay, and for very small displacement, you can say that arc length and this displacement, they will be almost identical. Okay, almost equal, right? So is that digestible? Yes, no? All right, good. So for, or let me just explain it. Okay, so this is a circle. Suppose the object moves from this point A to point B, and now I have taken a small displacement. Okay, so this is point A, this is point B, and now what would be, this is the distance covered, right, which is equal to length of the arc, and what would be the displacement? It's the line joining point A and B. Okay, and this displacement is small, so length of this line and this arc, they are almost equal. Yes, no? Okay, if I zoom out, you cannot even differentiate between the line AB and arc AB. Yes, no? Okay, good. So for small displacements or for small angle, the length of arc and length of the linear displacement, they are almost equal, right? And then using that, I can write the delta theta is just equal to delta r divided by r. And then one more thing, one more thing is, see over here, now how can you find out this delta theta? Delta theta is delta r divided by r. Okay, so one more thing is, if you see at this triangle, okay, this side and this side, they are equal, and this angle is delta theta, right? So now velocity is perpendicular to the radius, okay, because it's in tangential direction. So now if you move the radius by an angle theta, the velocity will also move with an angle theta, right? The angle that we have taken is delta theta. So if you move the radius by an angle delta theta, the velocity will also move, the perpendicular will also move by an angle delta theta. So that means if you think about this triangle and this triangle, they are similar. How? By, if we go mathematical, it is SAS test, okay? So this side and this side, length of those two sides would be equal, because the velocity has constant magnitude, okay? So VA bar's magnitude and VB bar's magnitude is equal, and then this angle would be delta theta. So two sides are equal, angle between them is delta theta, right? So then if you take ratio of this side to this side in this triangle, what you have taken is delta r divided by r, it gives you delta theta. So here delta theta can be found by taking delta v by v. Okay, can be found by taking delta v by v. This thing is clear? Yes, no? All right, good. So then delta theta can be also written as delta v by v. So then you can take this v on other side. So delta v is equal to, you can say, v times delta theta, okay, and then you just divide both sides of this equation by delta t. So you get, and apply this limit delta t tends to 0, okay. So you get instantaneous acceleration, right? So instantaneous acceleration is just equal to limit delta t tends to 0 v times delta theta by delta t. So what is delta theta by delta t? It is omega, change in angle or change in angular displacement, you can say, divided by time. So that is omega, and therefore you get this side is delta v by delta t, means it is acceleration. It is equal to v multiplied by delta theta by delta t, so that is omega, okay. So this acceleration is because of which thing? It's because of change in direction of velocity, and that's why we call it as centripetal acceleration. Okay, not, this is not the reason. So the reason is, this acceleration would be directed along radius and towards center. This acceleration would be directed along the radius and towards the center of the circle. That's why it is called as centripetal acceleration. But where does it come from, the centripetal acceleration? Because of change in direction of velocity, okay. So I am calling it centripetal acceleration, so I put suffix ac, suffix c, okay, a suffix c, c for centripetal, right, and it is equal to v multiplied by delta theta by delta t is omega. So this thing is clear. Is this formula clear for centripetal acceleration, everyone? All right, very good. So then you can use the formula omega is v by r. If you substitute that in this formula, then you get v multiplied by omega is v by r. So that is v times v by r. So v square by r. And if you substitute that v is equal to r omega, you get another formula. It is r times omega, that is omega square. So you have three formulae for centripetal acceleration. One is v times omega. Second one is v square by r. Third one is r omega square, and all three you need to remember, right? Okay, any confusion in this? Tell me, because this is a very, very important point. Okay, it's there in circular motion, it's there in gravitation, it's there in rotational motion. Right, no confusion, okay. All right, so this is the scalar form of the centripetal acceleration, and now I'm not proving it, I'm just telling it to you that its direction is along radius and towards the center. Okay, so if you take radius vector anywhere, let's say at this point, it will start, radius vector is the position vector of the particle in circular motion. So it starts at the origin, which you can call it as center of the circle. So center of circle, okay, and it's directed towards the position of particle. So this is along radius away from center, right? It's along radius away from center, the radius vector, and your centripetal acceleration is opposite to that. And that's why, see, you have centripetal acceleration equals to r omega square, but then it's directed opposite to r bar, and that's why I have put this negative sign. Okay, we need to put this negative sign. So AC bar is equal to minus of omega square r bar. AC bar is equal to minus of v square by r into r cap, and AC bar is equal to omega bar cross v bar. It's not v bar cross omega bar. This thing you will need to remember. Okay. Right. So then there are some similar relations which I am going to write now. So similar relations are the relation between linear quantities and angular quantities. So vector relations between the linear quantities and angular quantities. That's very, very simple. So see, if object moves along the circumference of circle, and suppose it goes from a point A to point B, okay, and this angle is very, very small angle, the angle is delta theta. Object is moving from point A to point B, right? So length of the arc is suppose delta s, it's very small. So angular displacement is small, this arc length is small, and we had seen that delta s is equal to what? R multiplied by delta theta. So this is scalar form, and in vector form, this delta s bar, okay, if you take very, very small value of that, it will be directed along the tangent. Okay, it's directed along the tangent. This is linear displacement in very, very small time. So this is linear displacement. I will write disp, okay, for linear displacement in very small time, in delta t tends to 0. Okay, very, very small time, right? So it is directed along the tangent. You can see that in very small time the object is always moving along the tangent, right? So then now what's the relation between this delta s bar, which is a vector quantity, r bar at this point, which is a vector quantity, and delta theta bar, which is also a vector quantity. So relation between them is delta s bar is equal to delta theta bar cross r bar. So you can check this, okay, using right hand thumb rule, right? Okay, so now we haven't seen what is the cross product of vectors till now, but I'm just stating the relations because we are talking about the circular motion, and these relations, they are related to circular motion. So I'm just stating it. So we'll take if we take cross product of two vectors, then we get the resultant is also a vector quantity. Okay, so delta s bar is equal to delta theta bar cross r bar. Then you have v bar is equal to omega bar cross r bar, and then there is another one, that tangential acceleration at bar is equal to alpha bar cross r bar. Right. So, do you know about the cross product? Yes, no? Okay, if you know, that's good. We are going to see the cross product, okay, when it comes, but these relations, they are related to circular motion, that's why I am stating it here. Okay, so I guess there should be no problem. We just need to remember this or by heart these. Okay, all right. So there is simple trick to remember this. Linear quantity will come first, and then, oh, what did I say? The angular quantity will come first and then followed by the linear quantity, and linear quantity is same thing only, it's r bar only everywhere, right, in these three. Okay, so magnitude wise we remember them, direction wise there will be a cross product. Okay, so delta theta bar, delta s bar is equal to delta theta bar. The angular term will come first, then cross sign followed by the linear term, right. Okay, v is equal to r omega, this is scalar form, but in vector form v bar is equal to omega bar cross r bar, and at bar is equal to what? It is r multiplied by alpha, but in vector form or in scalar form you can write anyway, right, r alpha alpha r, no problem, but in vector form the angular term will come first followed by cross sign and then the linear term. So similarly here, centripetal acceleration also we have seen, it's minus of omega square r bar. Okay, it's minus of v square by r times r cap. So these two tell you that it's directed along radius, but it is towards the center, but radius vector is directed away from center. Okay, it's along the radius but towards center, that's why the negative sign is there. But when you write it as omega times v or v times omega, if you want to write it in vector form, the angular term will come first, okay, that is omega bar, followed by cross, followed by the linear term, right. So same theme is there everywhere. This is clear? Yes, no? Okay, because they can ask a question like that sometimes. All right, good. Then here this should be very clear that omega, the centripetal acceleration, and v, all three are perpendicular to each other, right. Omega is directed along the axis. Now, what is an axis? If you think about a circle, a straight line passing through the center of the circle and which is perpendicular to the plane, it is known as axis. Okay, axis means for a circle a straight line passing through the center and perpendicular to circle. If circle is in this plane, circle is like this, what is an axis? A straight line which is perpendicular to this plane and passing through the center, right. So that is an axis. All right, good. Okay. So if there is any doubt, you can ask me. All right, good. So then we talked about the centripetal acceleration, which is due to the direction, change in direction, and we talked about the tangential acceleration, which is due to change in magnitude of velocity. So there are, if it is uniform circular motion, then there is no tangential acceleration, there is only centripetal acceleration. But in non-uniform circular motion, there will be two accelerations, one is the centripetal acceleration, one is the tangential acceleration. right? And how are they directed? Centripetal acceleration is directed along radius and towards the center. Tangential acceleration is directed like this. Okay, it is directed in tangential direction along the tangent. So what is the total acceleration in non-uniform circular motion? So it is vector sum of these two, vector addition of these two. So if you just apply the parallelogram law of vectors addition, so these two are perpendiculars to each other, right? So a bar, you can say it's equal to AC bar. It is also called as radial acceleration because it is along the radius. So it is also written as AR bar, okay, AC bar or AR bar, centripetal acceleration or radial acceleration, okay. And then there is tangential acceleration. So A bar is equal to AC bar plus AT bar, and if you want magnitude of that, then it's just square root of AC square plus AT square, okay. So magnitude of this total acceleration is just square root of the magnitude of centripetal acceleration square plus magnitude of tangential acceleration square. Right. So what is some example of non-uniform circular motion? So non-uniform circular motion, any vertical circular motion is non-uniform. So can you tell me the reason behind that? Anyone? If you take an object, suppose you take a stone, okay, and you whirl it in vertical circle like this, then its motion is non-uniform circular motion. What could be the reason? Reason is gravity, right? Gravity will change the magnitude of velocity. Yes, no? Okay. All right, good. So vertical circular motion is non-uniform circular motion. Okay. Then now we have seen what is centripetal acceleration, but then we'll talk about another method because there are problems based upon this thing. Okay, so centripetal acceleration using the calculus method, and this is very, very simple. Okay, so see, suppose the position vector of an object in circular motion is denoted by r bar, and we just want centripetal acceleration. That means our object is performing uniform circular motion. Okay, it is in uniform circular motion. So this is the position vector of our object at some time t. So suppose our object started from this point. So this point is point A, and it moves to the point B in some time t, right? It moves to the point B in some time t. So while moving, there is some angular displacement. So angular displacement is suppose theta. Okay, so we know what is angular velocity. So angular velocity is omega is theta divided by t, and therefore theta will be equal to what? Omega times t, right? Theta is equal to omega times t. Okay, just take the t on other side. So you got theta equals to omega times t. Okay, so this theta is equal to omega times t. Now what I will do is, this is the position vector of my object in the circular motion. I will just resolve it along two components, one along the x-axis, one along the y-axis. Okay, so I have resolved it along two components. So then after that, so I can write it as rx times I cap plus ry times j cap. Okay, so we have seen the resolution, we know how to do that. So now you tell me what will be rx and ry. Which one will be r cos theta? Which one will be r sin theta? Resolution.
Rx is r cos theta.
Rx is r cos theta and ry is r sin theta. Right? Always remember, through the angle cos component, away from angle sine component. Right? So Rx is r cos theta. So r bar is equal to r cos theta into I cap plus r sin theta into j cap. Then theta can be written as what? Omega t. So next step I am doing that. R bar is equal to r cos of omega t multiplied by I cap plus r sin omega t multiplied by j cap, right? So this is my position vector. Now I know change in position with respect to time is velocity. Okay, rate of change of position with respect to time is velocity. So to find out its velocity, what I will do is I will just take derivative of position vector with respect to time. So dr, change in r, is the displacement, right? So displacement by time is velocity. So then if you do that, you need to take derivative of this thing. So r you can take common, and when you take derivative of cos omega t, so what would be its derivative? Who can tell me derivative of cos of omega t with respect to t? Yeah, so derivative of cos is minus sine, okay, but then, okay, we have seen the method, right, when we discussed about the mathematical methods. So derivative of cos is minus sine. So let me write it here. I want to take derivative of cos of omega t, okay, with respect to t. So derivative of cos is minus sine. So I will just say it's minus sine omega t, but then I am not taking derivative of cos of t. That could be minus sine t. I am taking derivative of cos of omega t. So what I need to do is take derivative of this thing. Okay, this is cos of the bracket. So I will just say it's minus sine of the bracket multiplied by derivative of the bracket. And what's derivative of bracket? That's omega. So I have multiplied by omega. So this is known as chain rule, right? This is called as the chain rule of derivatives. Okay, remember? Yes, no? All right, good. So then take derivative of cos of omega t. So it is omega multiplied by minus sine omega t. Derivative of sine omega t is omega multiplied by cos omega t. Okay, derivative of sine is cos, so cos of omega t, but then multiply by derivative of omega t, that's omega. Okay, so that's why that omega is coming. All right, after that what you can do is you can take its derivative, take derivative of velocity, so you get acceleration. And here, since we have taken omega constant, that means we are talking about the uniform circular motion, right? And because it is uniform circular motion, there will be only one acceleration, that is due to change in direction of velocity, right? So just take derivative of velocity now. So if you take one more derivative of velocity, what happens? The sine omega t, if you take its derivative will be cos omega t multiplied by omega, right? And again, derivative of cos omega t is minus sine omega t multiplied by omega. So that multiplied by omega is there, no? We take it outside. So we have r times omega multiplied by another omega, which will come from derivatives of the sine and cos term. So you have r times omega square, and the remaining thing is there in this bracket. So that's minus derivative of sine is cos. Okay, minus sine was already there. So minus cos of omega t into I cap. Okay, plus derivative of cos is minus sine. So minus sine omega t into j cap. So what is this thing? If you take minus sine outside and take r inside, okay, so it is minus omega square multiplied by r cos omega t into I cap plus r sin omega t into j cap, and this is nothing but your position vector r bar. Okay, this is your position vector r bar. So this thing is clear, everyone? Yes, no? Right, very good. So now what do we need to remember from this derivation? So we need to remember, first of all, the resolution of this radius vector. Okay, so r bar is equal to r cos omega t into I cap plus r sin omega t into j cap if your object is moving in anti-clockwise sense. So can you tell me, if it is moving in clockwise sense, then what would be what will change here? So depending upon where it is starting from, cos will change to sine, sine will change to cos. There is a problem like that which was there in NEET. We'll see. Okay, but for now let me box this thing. Right, so this is the radius vector or position vector, you can say, and given that, or suppose given the circular motion, given the sense of revolution, etc., we should be able to write this vector and we should be able to find its velocity. Okay, this thing is clear? Yes, no? Right, is there a question in this? All right, good. So then there are, just like we have kinematic equations for linear motion, we have kinematic equations for circular motion too. Okay, so just linear quantities will become angular quantities, right? So we have v equals to u plus at. So just similar to that, we have omega, which is final angular velocity at time t, is equal to initial angular velocity plus angular acceleration times t. Change every linear quantity to angular quantity, corresponding angular quantity. So v is final velocity, so in place of that write final angular velocity. Then u is your initial velocity, in place of that write initial angular velocity, and a is acceleration, in place of that write initial angular acceleration. Okay, similarly you can say theta for this thing, s is equal to ut plus half of at square. You can say theta is equal to omega naught t plus half of alpha times t square, right? Just change u to omega naught and change a to alpha, and we have v square equals to u square plus 2as. Just like that, omega square is equal to omega naught square plus 2 times a will change to, the linear acceleration will change to what? Alpha, angular acceleration, and linear displacement changes to theta, angular displacement. This is clear, everyone? Right, good. And then if it is uniform, if you have uniform acceleration, then you can say average speed or average velocity. Okay, v average is just equal to what? U plus v divided by 2, right? We have seen this in straight line motion. So just like that, we have uniform, if we have uniform angular acceleration, then we can say this is uniform, uniform angular acceleration. Then we can say average angular velocity, let's call it omega average. It's just equal to what? Omega naught plus omega t, or we are writing it as omega here, right, divided by 2. Okay, and then see, omega can be written as 2 pi n then omega can be written as 2 pi n. So everywhere we can say that omega average can be written as what? So let's call this 1. So from 1 I can say what is omega average. So 2 pi multiplied by n average is equal to 2 pi multiplied by n, the final frequency, plus 2 pi multiplied by starting frequency or initial frequency divided by 2. So 2 pi can be cancelled out everywhere. So you get average frequency is equal to n plus n naught divided by 2. So this thing is clear? Yes, no, everyone? Right? And then now we'll see some problems based upon this thing. Okay. All right. So let's see some problems. The angular speed on a flywheel moving with uniform angular acceleration changes from 1200 rpm, rpm means revolutions per minute, to 3120 rpm in 16 seconds. The angular acceleration in radians per second square is. So this is from NEET 2022, very simple question. So what is initial angular speed? It's 1200 rpm, but it is not angular speed, it is initial frequency, right? It's n naught because it is given in terms of revolutions per minute. So it is 1200 rpm and I want to convert it to revolutions per second. So what should I do? Divided by 60. Okay, so this is revolutions per minute, right? You have revolutions per minute and per minute. So I want to change it to second. So 1 minute is 60 seconds. So that's why I am dividing by 60, right? Yes, no, this is clear. This is very basic thing, but I want to just make sure that everybody understands, right? So then divide by 10 to numerator denominator, 0 gets cancelled. Okay, we often say it in this way, 0 doesn't get cancelled. What happens is you can divide by 10 numerator denominator. All right, then 120 by 6 is what? 20. So this is equal to 20 rps. And what is n final one? It's 3120 divided by 60. So that is 312. 5s are 30, then you have 12, so 52. So 52 rps, right? So you got initial frequency, final frequency, and you want angular acceleration. So what is angular acceleration? Alpha is just equal to omega minus omega naught divided by t, right? And that is, in omega and omega naught you can take 2 pi common. So alpha is just equal to 2 pi multiplied by n minus n naught divided by t. So that is 2 pi, 2 times 3.14 multiplied by, or it's given in terms of pi, no? So let's keep it like that. All right, so let's keep it like that. So 2 times pi, n is 52 minus n naught is 20 divided by time is how many seconds? 16 seconds. So 52 minus 20 is 32. 32 by 16 is 2, right? 2 times 2 is 4. So 4 pi is the answer. Okay, this is clear, everyone? Okay, very good. Let's see next one. See, first we'll see very simple problems. First we'll see some recent problems, right? The angular speed of wheel of a vehicle is increased from 360 rpm to 1200 rpm in 14 seconds. So what is angular acceleration? Its angular acceleration is so this is also very simple question, same as that of previous one. So you have omega 1 equals to 2 pi n1, or let's do this, alpha is equal to what, 2 pi n1, or let's say n minus n naught divided by t. You can directly write down this formula. Then it is 2 pi multiplied by what is n. So n is 1200, final one is 1200 rpm. So you have 1200 divided by 60, because I want to convert it to rps, minus you have n naught, which is 360. So 360 divided by 60, okay, and divided by time is 14 seconds. Okay, so what we can do is we can take this 60 common and move it to the denominator, and then this 14 can be divided by 2, so that's 7. So you have pi multiplied by 1200 minus 360 divided by 60 times 7. So how much is this? 1200 minus 360, okay, 900, 840, right, 840. So therefore alpha is equal to 840 divided by 60 times 7. So I guess this is 422, right, 2 pi. Okay, so this is the answer, option B. Okay, good. Let's see next one. Two particles A and B are moving in uniform circular motion in concentric circles of radii RA and RB with speeds VA and VB respectively. The time period of rotation is same. Okay. The ratio of angular speed of A to that of B will be. Tell me. Yes, the ratio of angular speed of A to that of B will be. Let me read it once. Two particles A and B are moving in uniform circular motion in concentric circles of radii RA and RB. So radius is different, with speeds VA and VB respectively. The time period of rotation is same. Their time period of rotation is same. The ratio of angular speeds of A to that of B will be. Anyone? Option A. Indusha is saying option A. Okay, do you agree with her? That's simple, no? Angular speed is 2 pi by t, and it's given that t is same. So if t is same, angular speed would be same, right? There is no other variable. So t is same, omega will be same, and that's why it is 1:1. This is the answer. Right, good. Very simple question. Okay. All right. So these things RA, RB, VA, VB, they have given to confuse you, right? But it's very simple, because they say that time period is equal. Okay, at that moment itself the angular speed is equal. All right, let's see next one. A particle starting from rest moves in a circle of radius r. It attains a velocity v0 meters per second in nth round. Its angular acceleration will be. So tell me, particle starts from rest. So what is initial angular speed? Omega naught is equal to 0, right? 0 radians per second. What is initial linear speed? So let's call it as u. U is also equal to 0 because it's starting from rest, and it attains velocity v naught in nth round. Anyone? Okay, so see, this velocity is tangential, right? So velocity is increasing means there is some tangential acceleration. So can I use this equation v naught square? Okay, Yamini is saying it's option C. So let's check. V naught square is equal to u square. V square is equal to u square plus 2 times as. Can we use this? Okay, a will be tangential acceleration, so 2 times at into s. Can we use this relation? We can use, right? Initial speed is 0. Okay, Selva Kumar is also saying option C. Okay, let's check. So see, you should tell me what you are doing, right? Okay, so u square is 0, then you get from there tangential acceleration at, 2 times at into s is equal to v naught square. Therefore at can be written as v naught square divided by 2 times s. So now what is the distance covered? Okay, what is distance covered in n revolutions? The distance covered would be equal to n times of 2 pi r, right? Distance covered would be equal to what? N times of 2 pi r. So we have at equals to v naught square divided by 2 times of n into 2 pi r. Okay, so this is tangential acceleration, but you want angular acceleration. So this tangential acceleration can be written as r times alpha. So r times alpha is omega v naught square divided by 4 times n into pi r, 4n pi r, and if you just move this r on other side, then you get alpha equals to v naught square divided by 4 times pi. Okay, this was nr, right? 4 times pi n r square, right? So this is very simple, and yes, it is option C, right? So this is simple. Okay, many of you solved, but I was asking what to do, right? At that time you should speak up what to do, which formula to use. All right, this is clear. Yes, let's see next one. In the given figure, a equals to 15 meters per second square. So this is a is equal to 15 meters per second square, represents the total acceleration of a particle moving in clockwise direction in circle of radius r equals to 2.5 meter at given instant of time. The speed of the particle is, tell me. Total acceleration is given. Okay, total acceleration is sum of the centripetal acceleration and tangential acceleration, and question is, radius is also given. The question is, what is the speed of this particle at this moment? Anyone? Okay, you are solving or what? Thinking. All right, so let me tell. See, this object is moving in a circle and its total acceleration is directed like this. So, the angle between the radius and total acceleration is given, right? The angle between radius and total acceleration is given. So, I am just redrawing it. So, angle between total acceleration and radius is given. So, this angle is 30 degrees. So, now you can say that there would be some centripetal acceleration, right? The centripetal acceleration is just the radial component of this acceleration. So, this much is centripetal acceleration, this is AC and this is A, this angle is theta. So, what is the relation between AC and A? So, I can just say that AC is equal to A cos of theta, that is A cos of 30. Now, it is very simple. So, speed is asked. So, what is centripetal acceleration? It is just V square divided by R. Okay, it is V square divided by, they have taken capital R. So, I will also take capital R. So, that is equal to A cos of 30. What is cos of 30? Sin that is 1 by 2?
3 by 2.
Root 3 by 2. Yeah, root 3 by 2. So, then you want V square, sorry, you want V, so move R on other side. So, V square is just equal to A times R multiplied by root 3 by 2, and A is 15, R is 2.5, 2.5 times you have root 3 by 2. Okay. So, then you have 15 times 2.5. So, 15 times 2 is 30, 30 and 2.5. So, 37, 37.5, 37.5, right, 37.5, and then you have multiplied by root 3 by 2. Okay. So, root 3 is 1.732. So, you have V square equals to 37.5 times 1.732 divided by 2. That is 37.5 times 1.732 divided by 2 would be near about 0.8 something, 0. Let's take 85. 85, no, it won't be 85, 865. This thing will be something like that, 0.865. Okay. So, this thing will be little less than, what are the options? 4.5, 5, 5.7, 6.2. So, I guess this thing will be little less than 36. Okay. But of course, it will be greater than 25. So, I think it would be option C, right. Okay. Now, they have given difficult values, not that difficult, but some calculation, and I am just guessing it. So, tell me, what do you think? Is that correct, or is 6.2? I don't think 6.2 will be correct, because this thing would be lesser than 36. Yes. Okay, so check that whether it's correct or not. Tell me.
Correct, sir.
Correct. Okay, good. Then now the method is clear, this thing is clear, that thing is just calculation, and we hope it won't come in NEET. Okay, but this thing is clear. How to go given the acceleration, total acceleration to centripetal acceleration, just take a cos theta, that's it. Okay, so that part is simple, right? Okay, let's see next one. A particle moves in a circle of radius 5 centimeters with constant speed, and time period is this much, 0.2 pi seconds. The acceleration of the particle is, so this one is very simple. So acceleration is AC is just r omega square, okay, and r is 5 centimeters, is 5 into 10 raised to minus 2. You got the answer, very good. So omega is 2 pi divided by t, right? So omega is 2 pi divided by time period is 0.2 pi, that pi and pi gets cancelled, so this is 10. Good. So omega is 10, so omega square is 10 square. Yeah, so answer is 5 meters per second square. Very good, very simple question, right? There is nothing in this one. Let's see next one. A stone tied to the end of a string of 1 meter long is whirled in a horizontal circle with constant speed. If the stone makes 22 revolutions in 44 seconds, what is the magnitude and direction of acceleration of stone? Tell me. 22 revolutions in 44 seconds. So first of all, what is the time period? 2 seconds, right? 22 revolutions in 44 seconds. Okay, how will you find time period? It is time taken divided by number of revolutions. Number of revolutions, right? So this is just time taken divided by number of revolutions. So 44 divided by 22. Okay, so that's 2 seconds. So that's fine. But then what is the question? What is the acceleration? So again, you can find out acceleration. So it is just r omega square. AC is r omega square. That is 1 meter multiplied by 2 pi by t. So 2 pi by 2, right? 2 pi by t square. T is 2, means it is just pi square. You got pi square, and it is directed along radius and towards the center. So option A is the answer, right? Okay, this one was very simple, right? Okay, everyone. Okay, you might get bored of these questions because they are very simple, right? But they are asked. Okay, two particles having mass m, and this is c, this one is, then the ratio of angular velocity will be, two particles having mass m and m are moving in a circular path. Okay, that question was different. In a circular path having radius r and r, capital R and small r, if the time period are same, then the ratio of angular velocity will be. So now whatever is the mass, whatever velocity is given, if time periods are same, yeah, then ratio of angular velocity is 1, right? Don't need to think about what is their velocity, okay, what is the radius, etc. Time period is same, means angular velocity is equal. Okay, so kind of I can say repeated question, slightly different, but then in both of the questions they are saying the period is same, right? Okay, that's very simple. Then is it the same question? Two racing cars of masses m1 and m2 are moving in circles of radius r1 and r2 respectively. Their speeds are such that each makes complete circle in same time t. Okay, so the ratio of angular speeds of first to second car is 1:1. Yeah, good, Nikita. Option C. So this question I don't know. I have just taken till 1999, I guess. Yeah. So till 1999. So this question appeared first then. It might have come before also. I don't know. But then from that time, okay, in the questions that I have selected, okay, limited selection. In that too, there are three occurrences of same question, right? Okay, they are just changing the concept, context. Two particles, here there are two cars in two bodies, something like that. Masses are given, radius is given, so this one got repeated. Anyways, let's see next one. An electron is moving in a circle of radius 2 meters with speed of 4 meters per second square. Find the acceleration of electron. So tell me, which formula will you use here? Which formula will you use? V square by r, right? All right. So it is just 4 square divided by 2. And what's that? 16 by 2, 8 meters per second squared. Okay. So it was asked in AIMS sometime, right? So very simple question. Okay. If length of seconds hand of a clock is 10 centimeter, the speed of its tip is nearly. Tell me, how will you solve this one? Length of seconds hand of a clock is given. Okay. What is the speed of its tip? Yes, V just equal to 2 pi r divided by t. And what is time period of seconds hand of a clock? Time period is, okay, you're saying speed is 1. Let's check. So it's 2 pi r, so 2 times 3.14 multiplied by r is 10 centimeter, that is 10 into 10 raised to minus 2 in meters, divided by time period is 60. All right, so then this thing is 10 into 10 raised to minus 2. This thing will be 10 raised to minus 1, 10 raised to minus 1, right? Yes, 10 to the power minus 1. Then this thing is, oh, they are asking in centimeters per second, so we don't need to change this. I thought in meters per second, centimeters per second. Then this thing will be 3 times 2 nearly. Okay, so 6 times 10, yeah, nearly 1, correct. So answer is nearly equal to 1. Okay, so that is option E. This is from Kerala CE. Okay, and there are 5 options per question. So what do you think, which exam would be more difficult, NEET or this thing? If difficulty level of questions is same, but number of options are more in this one. number of options is more, that is more difficult, or number of options is less, that is more difficult? More options, right? Yeah, more options would be more difficult. If there are two options only, then even if you just tick on 50% of questions, I mean, sorry, if you tick on all questions, okay, and you don't see anything, okay, either it's A or B, then probability is that half of your answers will be correct, right? Anyways, let's see next one. A particle moves along a circle of radius 20 by pi with constant tangential acceleration. If the velocity of particle is 80 meters per second at the end of second revolution after motion has begun, the tangential acceleration is tell me. So velocity is 80 meters per second at the end of second revolution. So you have this thing v square is equal to, does it start from rest? Particle moves along circumference. If velocity of particle is 80 meters per second at the end of second revolution after the motion has begun, okay, so it starts from rest, right? So v square is equal to, you can drop u square, it is just equal to 2 times 80 into s, okay, and you want tangential acceleration only, so 80 is just equal to what? V square divided by 2 times s. In second revolution, what would be the displacement? Not the displacement, distance covered, you can say, okay, it's 2 times 2 pi r, right, because this is second revolution, so it's 2 times 2 pi r. For n revolutions it will be n times 2 pi r. And how much is this? Speed is 80, so we have 80 square, or here I will just keep it v square, and then you have 80 equals to v square is 80 square divided by 2 times 2 times 2 is 8 times pi multiplied by 20 by pi. So this thing will get cancelled out, okay, and this thing can be written as 80 times 80. So 80 by 8 is 10, 80 by 20 is what? 4, 4 times 10 is 40. So answer is 40 meters per second squared. Okay, so that is another simple question, right? This one is clear? Yes, no? Okay, good. Let's see next one. A body moving along circular path of radius r with velocity v has centripetal acceleration a. If its velocity made equal to 2v, then its centripetal acceleration is, okay, this is another variant of a question. So this is straightforward, right? Centripetal acceleration is equal to v square by r. If you don't change radius, velocity is made twice, then what will happen to the acceleration? It will become 4 times, no? Yes, no? Yeah, so it's option A. Good. So it will become 4 times. Right, velocity is made twice, acceleration is acceleration will just become 4 times. Okay. All right, let's see next one. What is the angular velocity of Earth? So you can very easily find it out. What is the angular velocity of Earth? So it is 2 pi divided by t. Tell me, what will be time period? Is it the time period of the revolution of earth around sun, or it's the time period of rotation? Yeah, 24 hours. Okay, it's the time period of rotation of earth, right? So then it's 24, 2 pi divided by 24 hours, so that is 2 pi divided by, you need to convert that 24 hours to seconds. So how many seconds? 24 multiplied by 3600. Then you will need to multiply that out. So it is 2 pi divided by 24. This is not correct. Okay, 3600 is also not correct. Yeah, so it will be option A. Okay. So this is simple, right? Okay. All right, let's see next one. A particle is moving with constant speed v in a circle. What is the magnitude of average velocity after half rotation? Tell me, what is the magnitude of average velocity after half rotation? A particle is moving with a constant speed v in a circle. What is magnitude of average velocity after half rotation, half revolution? Yes, anyone? Option B, 2v divided by pi, you are saying? Okay, let's check. So see, the particle moves from, let's say, A to B. So it will go to the diametrically opposite point. Okay, so this is half revolution. So therefore, you will have average velocity v average is just equal to what? Displacement divided by time. So what time will it take to go to the other side, meaning to complete the half revolution? Time taken would be just equal to t by 2, right? So it is displacement divided by time. Displacement, you can say it's 2r, and time taken is t by 2. You can move that 2 in the numerator. So what do you get? You get 2 times of 2, that is 4r by t. And then you have v is equal to 2 pi r divided by t, right? Because all of the answers are given in terms of v. So what we can do is we can write this thing as 2 pi r. I can write this as 2 times 2 pi r upon t. So what I have done is I have written this 4 as 2 times 2, but I have 2r only. Okay, then you need to multiply by pi, so you should divide by pi also. So that is 2 by pi multiplied by 2 pi r by t, so that is v. Okay, so answer is, yeah, so it's correct, 2v divided by pi. So it's option B. So that is, yeah, it is also simple, right? So Yamini solved this. Good. This is clear? Yes, no? All right, good. Then let's see next one. A particle is moving uniformly in a circular path of radius r. When it moves through an angular displacement theta, then the magnitude of corresponding linear displacement will be. Okay, a particle is moving uniformly in a circular path of radius r. When it moves through an angular displacement theta, the magnitude of corresponding linear displacement will be? This is the question. So this is a slightly different question. Let me explain this. So see, your object is moving, suppose, from again A to B, okay, and angular displacement is theta. So what is the linear displacement? So see here, linear displacement would be this much, right? So that is delta r, right? So this length is r, this length is r, okay, and this thing is delta r, this thing is delta r. This is the linear displacement. So now if you see all of the options, there is theta by 2, theta by 2, theta by 2 in all of the options, okay. So this linear displacement delta r has something to do with theta by 2, right? So what we can do is we can just draw a bisector of this angle. So it will bisect it in two halves, theta by 2 and theta by 2, okay. So let's suppose this point is O and this point is C, right? So then now if you take the relation between r and this delta r, or r and you can say delta r by 2, what will be the relation? You can take this angle, this is theta by 2, right? See, the angle is theta by 2, this angle is theta by 2. Let me use this color, theta by 2, sorry, theta by 2. Okay, so if you take sine of theta by 2, if you take sine theta by 2, what do you get? It's equal to the opposite side is BC, okay, or you can say delta r divided by 2. So delta r divided by 2 divided by the hypotenuse. How much is hypotenuse? It's r. So delta r by 2 upon r, right? Then you can take that 2 in the denominator and then you get 2r, you can move it on other side. So here you get delta r is equal to 2r multiplied by sine theta by 2, right? You will get 2r multiplied by sine theta by 2. This thing is clear? Yes, no? Everyone? Okay, good. So now this question is not asked in NEET, but it is asked in different exams which have similar difficulty level as that of NEET. Okay, so that's why I have taken it. So see, displacement is 2r sine theta by 2, so it is option D, right? Okay, so now you can just remember this thing, and this thing will be helpful for us also. For an example, suppose, okay, for an example, suppose object moves from A to B, okay, just an example. And the angle covered or angular displacement is 90 degrees. Let's say angular displacement is 90 degrees. So what would be the linear displacement? So theta is equal to 90 degrees. What would be linear displacement? Delta r just equal to 2r multiplied by sine of theta by 2. Sine of theta by 2 is 45 degrees. Okay, so that's 2r multiplied by sine 45 is 1 by root 2. So then you get root 2 times r, right? What do you get? Root 2 times r. Okay, so now this kind of any angle could be given. Okay, 90 degrees is a possibility, right? Because they have I mean they take 90 degrees, 180 degrees, something like that, but they can give you 270 degrees or 120 degrees, whatever. So even if it is 120 degrees, Now based upon whatever we learned, we can find out how much is the linear displacement. Okay, we can just resolve it, etc., but we don't need to do all those things. We can simply remember this formula, that linear displacement is just equal to 2r times sine theta by 2. Okay, linear displacement is just equal to 2r times sine theta by 2. So if angle is 120 degrees, just take sine of 60. Okay, so what would be linear displacement? 2r multiplied by sine of 60. This thing is clear? Yes, no? Okay, so just remember this thing as a fact, as a trick, you can say. Okay, good. All right, so just remember this thing, because they can ask about the linear displacement. Okay, let's see next one. A ball is moving in circular path of radius 5 meter. The tangential acceleration at any instant is 10 meters per second squared, and net acceleration makes an angle of 30 degrees. This is similar to what we had seen, right? With centripetal acceleration, then instantaneous speed is. Okay, tell me. So what's given? Tangential acceleration is there. Tangential acceleration at any instant is 10 meters per second squared. So let's suppose this is tangential acceleration and this is 10 meters per second squared, and something else also is given, that net acceleration makes an angle of 30 degree. So net acceleration something like this, let's say, right? Let me reduce tangential because I want this angle to be 30 degrees. Okay, so this is net acceleration, a bar, this is tangential acceleration, and this is centripetal acceleration. Okay, so what is given? It makes an angle of 30 degrees with the centripetal acceleration. So this is 30 degrees. Then the instantaneous speed is, tell me. It is along the tangent. Yeah, now it's good. No, it's same. All right, so assume that it's a tangent. Okay, it's vertical. Tell me. Till that time I will try once more. Okay, this one is not better. Yeah, good. Anyone? Did somebody comment? Okay, so see, you want centripetal acceleration and this acceleration, angle between them is given. Option B. Yamini is saying option B. Let's check. So this angle is given, right? Then now see, you can just take tan of theta here. Okay, it is equal to this opposite side, which is tangential acceleration divided by centripetal acceleration, right? So tan of theta is tangential acceleration divided by centripetal acceleration. And you want speed, no? So it is just v square by r. Centripetal acceleration is v square by r. So that is equal to 80 divided by tan theta. That is equal to, how much is this acceleration? 10 divided by tan of theta is 30 degrees. Tan of 30. What is tan of 30? 1 by root 3, right? So therefore it will be 1 by root 3 in denominator. So 10 root 3 in the numerator and that is your v square by r. Then you have r equals to 5, so move that on other side. So v square is equal to 10 times of root 3, that is 1.732 times 5. Okay, so this thing is 50 times 1.73, so I will just take 173 divided by 2. Okay, so I have multiplied by 100 and dividing by 2.
We have 50 by root 3 option, sir.
50 by root 3?
Option A, sir.
50 by root 3. 50 root 3 you are saying. Okay, 50 root 3, that is v square, no? We want v. Right, no problem. So you have 173 divided by 2, so that will be 170, so that's 86.5. So 86.5. So this is, yeah, Yamini said option B, no? You're correct, it's option B, 9.3 meters per second. Good, because 9 square is 81. Okay, so this will be little bit more than that, right? So you solved this way, Yamini, or did something else?
I took v sine theta equals to tangential acceleration.
V sine theta, a sine theta.
A sine theta equals to tangent.
Yeah, a sine theta is equal to tangential acceleration and a cos theta equals to centripetal, like that.
Yes, sir.
Okay. Yeah, it's same thing. You can save little bit of time if you just take the ratio, right? But whatever clicks, right, while solving the numericals. Okay, very good. Let's see next one. The position vector of a particle is this thing. Okay. The velocity vector of the particle is, tell me, parallel to position vector, perpendicular to position vector, directed towards the origin, directed away from the origin. Tell me. So option B, very good, it's perpendicular to position vector. So see, now here we are discussing circular motion, and here we know that position vector and velocity vector, they are perpendicular to each other. But if this thing is given, this thing comes in the exam, right, and then you should recall that this is position vector of a particle, it's given nowhere, right? It is position vector of a particle performing uniform circular motion. You should remember that. Okay, so that's why we took that calculus method. Okay, so you should remember this. This is the position vector of a particle performing uniform circular motion, and if it is uniform circular motion, then radius vector and the velocity, they are perpendicular to each other, right, because velocity is along the tangent. Oh, I zoomed it and perpendicular became parallel. Anyways, this is clear, yes, no? Good. All right, let's see next one. So a particle moves so that its position vector is given by this thing. So now they are calling x cap to I cap. Okay, as we discussed, the unit vectors along x, y, z axis, they can be written as I cap, j cap, k cap. They can be also written as x cap, y cap and z cap. Okay, there is no problem. Okay, where omega is constant. This is from NEET, I guess 2021, I guess. Okay, which of the following is true? Velocity and acceleration both are parallel to r bar. Velocity is perpendicular to r bar and acceleration is directed towards the origin. Okay, is this thing correct? Yes, no? Velocity is perpendicular to r bar and acceleration is towards the origin. Origin means towards the center. This one is correct? Yes, no? Yes, this one is correct, right? Yeah, so this is very simple. Okay, so again, it's not written that particle is performing circular motion, but given this, it should click to us that particle is performing circular motion. Okay, So please remember this position vector. All right, let's see next one. Radius of a circle, the period of revolution, initial position and the sense of the revolution are indicated as shown in this figure. Y projection of radius vector of rotating particle P is, Y projection means Y component. Tell me, anyone? Okay, see, you have this particle which is revolving in the clockwise sense, right? It's given here, it's revolving in clockwise sense. So suppose this is the position vector. Now which angle will be theta? This angle or this angle? This angle will be theta, right? This angle is equal to theta, and then you can find out Y projection or Y component. So what will be Y? If this is R bar, then Y is equal to R cos theta, right? Okay, Y is just equal to R cos theta. That is, Y is equal to R cos of, what is theta? Omega t. Okay, let me write it here. Y is equal to R cos of omega t. And what's given there? Radius is given. See, the radius is given 3 meters. What else is given? Time period is given 4 seconds. That means you need to write it in terms of time period. Okay, so radius is 3. So it is 3 cos of, what is omega? Omega is 2 pi by capital T. Okay. And what is capital T? Capital T is 4 seconds. So 3 cos of 2 pi divided by 4 T. So what's that? 2 by 4 means pi by 2, right? 1 by 2 times pi is pi by 2. So it is 3 cos of pi by 2t. So this is the answer. Okay, so it is option C. Right? Got it? Yes, no? Okay, good. So see, this all comes from that calculus method. Okay, so sometimes they can ask about what is the velocity. They asked about what is the position vector. Here Y component, they are asking about the Y component. So sometimes they ask about position vector, whether the velocity is perpendicular or not, right? So you need to remember all that. Okay, let's see next one. Wheel is rotating at 900 rpm about its axis. When power is cut off, it comes to rest in 1 minute. This is simple one. The angular retardation is, so I will skip this one, or I can just say that when it comes to rest, what will be omega? Omega will be 0. What is omega naught? Omega naught is, you have n naught is given. Okay, it is equal to 900 rpm. So it is 900 divided by 60, right? So that is 15 rps. Okay, so what is alpha? Alpha is omega minus omega naught divided by t. Just put the values. So omega is, this is 0 minus 2 pi multiplied by n is 15 divided by 1 minute is 60 seconds. So actually we have solved it. Okay, so 2 pi by 4 is pi by 2. So the answer is minus pi by 2. This much is acceleration. So the magnitude of retardation, retardation means negative acceleration. Okay, angular retardation is pi by 2. That's the answer, right? So this is very simple. Yes, Selva Kumar. Good.
Yes, sir.
Good. Let's see next one. So let me just check whether it's worth solving. Okay, let's solve this one. The motor of an engine is rotating about its axis with an angular velocity of 100 revolutions per minute. It comes to rest 15 seconds after being switched off. Okay, comes to rest 15 seconds after being switched off. Then what is the number of revolutions made by it before coming to rest? Tell me. How will you solve this? So one way to solve is, see, theta is equal to omega naught t plus half of alpha times t square. So here you will need to find out alpha, here you will need to find out omega naught, right? How can you find out alpha? So alpha is just omega minus omega naught divided by t. You can find it out. Okay, omega is given, angular velocity is given in terms of revolutions per minute. So you can find out omega naught, which will be 2 pi n naught. So that is one way. And what will be the angle covered in what is the number of revolutions? Okay, so we'll get the angle. So in one revolution the angle covered is 2 pi. For n revolutions, you can say that angle theta is equal to what? N times of 2 pi. Right? Yes, no? Is this thing clear? Everyone? Okay, so this is one way to solve it. But then we can do a better job. Right? Yeah. So see, what we can do is we can find out average frequency. What is average frequency? Final frequency plus initial frequency divided by 2. That's it. So final frequency is 0. What is initial? Initial is 100 revolutions per minute. That means 100 by 60 revolutions per second divided by 2. Okay, so that is 10 by 6 means 5 by 3. So this is 5 by 6. That 2 is there in the denominator. This is 5 by 6. Okay, this is revolutions per second. And how many seconds are there? How long does it revolve before stopping? 15 seconds. So that is given. Okay, so we can just say so n average is just equal to, or not n average, total number of revolutions is just equal to average frequency, n average multiplied by time. Because what will be average frequency? Total number of revolutions divided by time. So what will be total number of revolutions? It is just average frequency multiplied by time. So let's call it n. So n is just equal to average frequency we calculated, it's 5 by 6 times 15. So that is 15 by 6. I can divide by 3. So that's 5 times 5 divided by 2. 25 by 2. 25 by 2 is 12.5. Right? 12.5 revolutions. So this is how we can solve it quickly. Okay, this thing will take time, considerable time. You can try it. This thing will take time, this method. Okay, so this second method is clear? Yes, no? Everyone? So the answer is option A. Right? Good. Then now let me check the questions. Okay, this I will leave. Okay, let's see this one. A particle is moving in a circle of radius r with constant speed v. The change in velocity after the particle has travelled a distance equal to 1/8 of the circumference of circle. Tell me, change in velocity after the particle has travelled distance equal to 1/8 of the circumference of circle. So if it travels 1/4, this thing will be 1/4. So 1/4, right? So for 1/8, how much will be the angle? It's 45 degrees. Okay, or you can say it's pi by 4. Theta is equal to pi by 4. So what will be change in velocity? Tell me. Speed is constant. Okay, see, you have this relation. If you remember, we just saw it. Delta r is equal to what? 2 times of r multiplied by sine of theta by 2. We have this relation, right? So then what will be delta v? We saw one radius triangle and one velocity triangle. They are similar to each other. So delta v in similar fashion can be written as 2 times of v sine of theta by 2. Okay, this thing is clear? Yes, no? Everyone? Okay, good. So then you can just say that it is 2 times of v sine of theta by 2. But what is theta by 2? So here there is little problem. Sine of theta by 2. What is theta? What is theta? Theta is pi by 4. Okay. So what will be theta by 2? It's pi by 8. Right? It is pi by 8. Okay. So then this angle would be 22.5 degrees. Okay. This is theta is equal to 45 degrees. So half of that is 22.5 degrees. So how can you find out sine of that? Can you find out sine of that? Anyone? So see here, I will tell you 2 ways. First is the intuitive way. So just look at the options. Can it be 0? Of course not. Sine 0 is 0. Sine of 22.5 degrees is not 0. Okay, 2v. Sine of this is 22.5 degrees. Okay. So sine of 22.5 is not 0. Then look at the other options. So for which angle sine is 0.5? For which angle? This is, of course, for which angle it is 0.5? It's 30 degrees, right? For 30 degrees it is 0.5. Okay. So sine is 0.5, this thing is 0.5. Then, okay, if the angle is 30 degrees, then this thing will be 0.5. 0.5 multiplied by 2. How much will you get if, if the angle is 30 degrees? 0.5 times 2 is 1. So your answer would be V. So if this angle is 30 degrees, your answer would be equal to what? V. But then if it is little bit less than that, what will be your answer? So your answer should be this thing. This thing is clear? Yes, no? Okay, everyone. Okay, good. And then now if you insist on solving it, so there is a way. Can you tell me what's the way? Okay, so see, we had seen this formula, 1 minus cos of 2 theta is 2 sine square theta, right? Similarly, I can say 1 minus cos of theta is equal to 2 sine square theta by 2. Take that 2 on other side. So sine square theta by 2 is equal to 1 minus cos of theta divided by 2. Okay. So now take theta equal to 45 degrees. So your theta by 2 will be equal to what? 22.5 degrees, right? So you have sine of 22.5 degree squared is equal to 1 minus cos of 45 degrees divided by 2, and this thing is 1 minus cos 45 is 1 by root 2 divided by 2, right? Then this thing will be root 2 minus 1, so that is 0.41. Okay, root 2 minus 1 divided by its 2 root 2. Okay, so this is lengthy. Okay, and then this is equal to 0.4 divided by root 2 times 2. So you can say it's 0.2 divided by root 2. Okay, or you can say it is, don't know, 2 times 10 0.1 divided by root 2. So again it will be root 2 times 0.1, so 1.41, 0.141, right? So that is sine of 22.5. Then no, it is square of that. Then find out its square root, and then you will get the value. Okay, if my calculation, this thing is correct, but this is how you can solve it. This thing is clear? Yes, no? Okay, but we don't have this much time, right? We don't have this much time in NEET. So if there is a question like this, what we can do is we can just look at the options and we can think, okay, sine of 30 is 0.5. If I take 30 in place of 22.5, answer should be closer to that. Okay, the value of sine goes on increasing from 0 to 90 degrees. Okay, sine 0 is 0, right? Sine 90 is 1. So it goes on increasing gradually. So if I take 30 degrees, answer should be closer to that, but little bit less than that. Sine of 30 is 0.5. 0.5 times 2 is 1. So that's why for 30 it is V. For 22.5, the answer should be little bit less than V. Not very less, but little bit less than V. So that's why I am taking this. Okay, that is clear, right? Good. So now again, this is based on the same trick, right? Delta R is equal to 2R sine of theta by 2. So just remember this formula and these kind of questions will be solved then. Okay.